guys, this is another tutorial by Codeworks. In this tutorial I thought of discussing merge sort. Now, unlike other tutorials where I practice at least once before um, doing it in front of you, in this tutorial I'm going to do it first hand without even practicing once, so that you guys can get a first-hand experience what it is like to make the mistakes. As it is first-hand, obviously I'm going to make some mistakes, and you're going to see and understand where I'm making the mistakes and how I'm rectifying it. So, a word, so something I should say now, that is, this tutorial is going to be a bit longer than the other tutorials. Okay, um, let me first discuss the merge sort before I proceed to the actual coding. Okay, suppose this is our array here. It has a distorted shape, but don't mind its shape at this moment. Okay, suppose the elements are 2, 1, 0, 4, 3, 11. That's it. Now what merge sort does, it recursively breaks down this array and um, sorts each individual subarray, and finally combines the sorted subarrays so that the original array gets sorted. It's like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, there are 6 elements. So this, what this algorithm would do is it would break this array, which contains of 6 elements, into two halves. These 3 elements and 3 elements, like this. One part goes here, another part goes here, like this. One part and the other part here. Okay, the first part becomes 2, 1, 0, then 4, 3, 11. Now, merge sort algorithm is again applied on this smaller subarray and this smaller subarray, so that it again divides each of this subarray into two different yet smaller subarrays. Um, one of them would be 2 here, then 1, 0, and here would be 4 and 3, 11. Now this and this subarrays can be further broken down, and this merge sort algorithm would again be applied on these subarrays, this one here, subarrays, to further break them down like this. 1 and 0, and here it would be 3 and 11. Now this subarrays here, namely 2, 1, 0, 4, 3, 11, these cannot be further broken down as they contain one element each. So now uh, now another algorithm um, would be executed, which would sort this subarray to attain the final bigger array. Means these two would be sorted here to sort this array. It would be 1, 0, 0 would come here and 1 would come here. So this thing would now be 0 and 1, like this. Now in this case same thing happens, as it's already in the proper order. 3 and 11. So nothing actually happens here. 11 goes here, 3 comes here. Then here it's 2, 0, 1 here. Now what this would do is, um, this the second algorithm which I was talking about, which would um, sort this array, would also take place on these two subarrays, and it would in turn sort this subarray, and this would become now 0, 1, 2, and same thing would happen here as well, and this would become 3, 4, 11, and same thing would happen on these two subarrays, and the final array will get sorted here: 0, 1, 2, 3, 4, 11. So this is a recursive method of sorting uh, array, and it has good efficiency. So let's dive into the actual coding now. Okay, I'm going to start the coding process now. Let's save it as mergesort.c, mergesort.c. Okay, let's begin with including the file, standard library header file. Include stdio.h, standard interpreted file. Then let's include stdlib file, standard library file, stdlib.h. Okay. Now, first I'm going to write the merge sort function, not the merge algorithm, the merge sort function. Okay, I was talking about two algorithms, one that would break the array into subarrays, and the other which would join them. The one which breaks the array into the subarrays recursively, it is the merge sort function, and the other array which joins the subarray to form the bigger array, it is called the merge function. Let's write the merge sort function. Void merge sort, void merge sort. This would take in an array in AR or lower index, low, and a higher index are the left and the right. Left is for low and right is for high. Okay. Then if left is less than right, means if the array is at least of size 2. If it is of size 1, then left equal to right, as there is only one element. So this condition checks if the array is of size 2 at least. If it is of size 2, then let's define m, when m equal to 0. Now m is the middle element, left plus right by 2. M is the middle element. Then I would call the merge sort algorithm once more. Actually twice. I would call the merge sort algorithm twice. Paste on the same array. Now, actually, what I'm trying to do here is I'm trying to break the original array into two subarrays. So I will have to call the merge sort function twice. First on the first part and second time on the second part. For the first time, the left would be left and the right would be m. And for the second part, merge sort on the same array m plus 1 r. Okay, now after I execute these two functions, I can assume that my array is sorted. It's obvious that when I execute this function, it's a recursive call to this function, and so things will happen inside this function as well as this function. But after both of them are executed, I can assume that the two subarrays which I have made now is sorted. Now I'm going to merge them. Merge AR. Let's name it merge array. Merge array AR left, middle, right. Let's give the three um, location. Actually, it's my neighbor's dog and it keeps barking all the time. Sorry for that. Anyways, now I'm going to make the merge array function. It's also a void function, void merge array, because it's not going to do anything. Merge merge array. As you can say, it's going to take in 4 arguments, integer array first, and the left, then the right, no, then the middle, sorry, then the right. Okay, sorry guys, it would be a comma here, like this, comma, then okay. Now what this would do is, okay, I'm showing you now. What this would do is, suppose this was my array here. For simplicity's sake, let's consider to be 1, 2, 3, 4, 4 elements. Suppose the elements are A, B, C, but it doesn't matter. It's going to divide these two. This, yeah, this set of instructions would divide this entire array into two parts. Here, like this, A, B, and here C, D. Now whatever happens inside this call or this call is not our headache, but after both these calls are executed, we can assume that these two elements are in this sorted manner and these two elements are in this sorted manner. Now we have to sort this array by placing these elements in their correct position in this array. Now the merge array function is called, and what this does is, actually, as you can see, it takes place at this level. At this level, this function is called merge array is called at this level only, and it takes two parameters: the left index, the right index, and the middle index. And what this function would do is, it will construct and construct a left array, a right array with um, with the indices, left array containing the elements from index L to M, and right array would contain elements from indices M plus 1 to R. After constructing this array, however it may be, how many elements, we'll see that later. After making this type of arrangement, this would finally place the elements here to the original array in the correct position. Now I'm going to show you how this is actually done, but this is the main concept. You must understand how this merge array function would break the original array into two arrays, and how actually the breaking takes place. After you understand the breaking, I shall show you how exactly the merging would take place. Okay. Now, to break the array, it will be broken into two subarrays, the left subarray, the right subarray, and the number of elements of the left subarray would be in, suppose, NL for the left subarray and NR right subarray. NL means number of elements of the left subarray, and NL would be equal to N minus L plus 1, and NR number of elements of the right subarray would be M no, it would be R minus M only. Okay, let me show you how this happens. Suppose the array is of 4 elements, and what M would do here is L plus R. Okay, let me enclose within parentheses to be on the safe side. L plus R by 2, and now L is 0 because array indices start from 0 in C and most other programming languages. Actually, I don't know if any language starts with 1. Anyways, in C starts with 0. So 0 plus R would be 3 here as it contains 4 elements. So 0, 1, 2, 3. R is 3. M is 0 plus 3 by 2 means 1.5, and 1.5 would be rounded down to 1. So M is equal to 1. And what my left subarray would hold is the elements 0 and 1. The right would hold elements 2 and 3, and NR number of elements the right subarray equal to R minus M means 3 minus 1 equal to 2. So our theory and the actual value which we are getting, this NR, is same. We calculated that it should contain 2 elements, the second last and the last element. There's element at an index 3 and element at index 2. So this is what is happening here, and the NL number of elements of the left array would be M minus 1 plus M minus L plus 1. Now M is 1, L is 0, so 1 minus 0 equal to 1 plus 1. 1 minus 0 plus 1 means 2. So N1 is also coming 2. And which two elements it would hold? It would hold the first element and the second element. Means it would hold the element at index 0 and at index 1. So NL and NL and NR, we saw how to calculate NL and NR. It's pretty easy mathematics, it's not very difficult. Now I'm going to insert the values. No, actually I'm going to declare the array now, L of elements N1 and R. Okay, let's take it capital L, and R of elements. Okay, now I'm going to define the right subarray of elements N2. Then I'm going to fill up this array. Let me take a iterator I. for I equal to 0, I is less than, wait, it would fill, m would be, if number of elements is 4, m would be 3 by 0 by 2 is 1.5, you 1, so 0 and 1 is element, 0, okay, I less than equal to m, I plus plus plus. Now left subarray is L plus I equal to, okay, no, left subarray is I equal to original arrays lower means left plus I, and okay, up to this. Okay, now what is happening here is left subarray now contains only two elements, and I would range from 0 up to 1, 0 and 1, two elements. So I 0, I at position, sorry, L at position 0 and L at position 1, and it would get filled, it will get populated by arrays position lower plus I. First element is lower plus 0, then lower plus 1. Okay, this is how it's getting populated. Now this was now I can't copy actually this. Now I equal to m plus 1, m plus 1. Now why this plus 1? Plus 1 is because it would fill up the right subarray from the elements after n, means if n is 1 in our test case, it would get filled by elements at index 2 and 3. So m plus 1, m plus 1 is 2, then 3. I less than equal to r, and r is 3, so less than equal to I plus plus. As you can see here, after this statement I is already m plus 1, but just for clarity's sake I am writing this code again, m plus 1, explicitly defining it. Anyways, then how it will get populated? Right subarrays I, okay, 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 no, actually I made a mistake here. Okay, I made a mistake here. How? Like this. See, how many times this loop would iterate? This loop would iterate up to nl times. Number of elements of the left array is nl. Iterate up to nl times, and this would iterate up to nr times. So nl times, I already have nl value here. So why would I do all this thing? So I equal to 0, I is less than equal to nl, number of elements of left array I plus plus. Once do now, same code will come here. I equal to 0, I less than equal to nr, number of elements of right subarray I plus plus. Now right subarray's ith position would be populated by original arrays m plus 1 from m plus 1th position plus I up to r. So you must be thinking how this is happening, so let me just demonstrate it. So suppose our array, which we have been talking about, of 4 elements, um, 2 1 3, say 7. Then m is coming to, this is initial position 0, is 3 here. M is equal to 3 plus 0 by 2 means 1.5, which would be rounded down to 1. The left subarray would contain elements from 0 up to 1, means these two. The right subarray would contain elements in the right portion, that is from m plus 1 up to uh, these two elements. Now, what this does is I equal to 0 to number of elements of the left subarray I plus plus, then L I equal to AR L plus 1. Okay. Now, this is the left subarray, suppose, of two elements NL, has defined it, NL equal to 2, so two elements. Now, L's ith position, and at the beginning I equal to 0, so this position will get populated by this array's left plus I equal to 0, so 2 would come here. Then I moves forward, then I equal to 1 is this position, and L plus I means 0 plus 1 would come here. Same thing happens for the right subarray as well. It's pretty intuitive, I should not discuss it. Okay. Let's move to the algorithm. Okay, my both my arrays are filled now. Now let's assign a counter which would um, start from 0, 0th position of both the arrays, and which would go up to the length of each of the array, the left array and the right array, and it's I comma j, two counters. So let's initialize I equal to 0, j equal to 0. Now while I is less than equal to, while I less than equal to NL and j less than equal to NR, what would happen is the original array's elements would get modified. The elements would get placed in their correct position. Okay, let's assign another, declare another variable k, which would iterate in the original array, the bigger array, and the subarrays. Now k is also 0 at the beginning. K equal to 0. While I less than equal to n1, j less than equal to nr, sorry, I less than equal to nl, not n1. Okay, now what I will do is, if the ith element of the left subarray is less than jth element of the right subarray, then original arrays k will be equal to left subarrays. This would be I, and now same thing would take place with the right subarray. Now paste, while okay, here's something else would happen. Now I have to increment the value of I plus plus, and increment the value of k plus plus, because these elements at these indexes are already getting used. Now if j is less than nr and j, okay, shit. Okay, I'm sorry for that. I plus plus, and here this part will get copied. Okay, where is the copy? I don't know, it's copy command. So control plus C, control plus V. It's not F, it's IF. If left of I is less than, it's greater than, then AR equal to R's J, then J plus plus, and at each of these we increment K, so K plus plus here and another K plus plus here. Or what you can do is you can cut both of these and just this is after this if statement. It would have the same meaning, but just for clarity I increment it at each of these if statement blocks. Okay, this while is done. Now while I is less than number of elements of the left subarray, while kth element, I'm sorry, while I is less than number of elements of the left subarray, kth element of AR equal to ith element of left subarray, then I plus plus, K plus plus, increment both the values. Then I will do the same thing with the right subarray in case, oh shit. Okay, in case of any leftover elements, I, J, N, R, equal to same thing actually as in the case of left subarray. Let's change I to J and L to R. But this two blocks, what this is doing is actually see the condition here. If I is less than equal to number of elements of the left subarray and J is less than equal to number of elements of the right subarray, then this thing takes place. Now what happens if J is more than NR and I is still less? Then this while loop would break out, means the control would break out of this while loop. In that case, to fill in the remaining elements, the leftover elements, these two while loops are constructed. Now actually it won't be I less than equal to an L, it will be only less than, because I less than equal to n L. So in our trial case, n L was 2 and R was 2, I equal to 0, 0, 1, 2 means 3 elements. That's not true, it's only 2 elements, so less than n L. And this is it. This is the merge function, merge array. This is the merge sort. Now we just have to define an array. Let's call it int main, return 0, not O, 0, yeah. Now I am going to define the array. Be an integer array, so int, okay, int AR of say 10 elements equal to say 5, then 7, then 1, then 6, then 70, then 2, how many have I made? 1, 2, 3, 4, 5, 6. More 4 elements. 8, 0, 12, 3. Okay, my 10 elements are constructed. Now I'm going to call this merge sort function. As you can see here, L will be 0 and R will be 9. So let's call the merge sort function. Merge sort. Let's pass the elements AR 0 9. Okay, this should do. Now let's print the elements for I equal to 0, I less than 9, I plus plus. Printf print the elements, that is %d. Let's give a space here, popularity AR I element. Now I is not defined yet, so let's define it here, comma I. Okay, let's keep our fingers crossed and let's run this piece of code. Okay, there is an error. Let's see. Error, my error is not declared in this scope. Of course, we have to cut this code here and we gotta paste it before merge sort function. Let's run now. Okay, what is it? Error n1 is not declared in this scope. N L, where is N L? Let's see. N. Oh, I'm so sorry. It's N1, it's not NL. It's N1. It's not defined in scope. N2 is not defined in scope. Okay, yeah, of course. N1 and N2 is not. It's not defined. N1, N2. It's not N1, N2. I'm so sorry. It's not N1, N2. It's not N1, N2. It's NL, NR. I'm being confused actually because I've been recording for quite some time and let's see. Okay, something happened here. It's not working as expected. Okay, what could be the problem here? An L here, an R here. I could be 0 up to yeah, L plus I j q equal to 0 and okay. Okay. Mm-hmm. Mm. Mm. Okay, what could be the problem here? L plus R everything seems to go to 1, 2, 3, 4, 6, 7, 8, 9, 10, 0, 9, 0. And so let's bring the elements first. Let's test it here. Okay. 5717. Okay. Something there's some problem with our logic because it's not working as expected. Let me just find the error and I shall continue the video because otherwise it may take too long and you have to wait for me to find the error. After about half an hour of debugging this code, I finally found out where the error was, and you wouldn't believe me. It's a very simple error. Okay. Actually, I lost track of what I was doing, uh, because in the debugging session, I actually use printf function a lot. I print at each stages to see up to where the output is coming as expected and where it's causing the error. And finally, I figured out what was the problem. It's very simple here. In this case, just see k equal to L. I wrote it as k equal to 0, but it will be k equal to L. It won't be equal to 0. If I correct this code, it's working absolutely fine. Is there anything which I have corrected? Okay. One more thing we have corrected is um, I equal to 0, I less than equal to 9. It's not less than 9. I wrote it as less than 9. It will be less than equal to 9. But this is it. Just see the output now. This is my unsorted array, and this is my sorted array. As you can see, it's sorted, and the time complexity of merge sort algorithm is O n log n. It's a very good sorting algorithm, and it's it has some concept. It's not that difficult, but still it needs some concept. And go through this video once more to see it, and I hope I could make it clear to you, and that in a simplified manner. If you like this video, do hit like and do subscribe for more videos like this. In the upcoming sessions, I will be making videos on basic C syntax like array, function, pointers, and other concepts which students normally face trouble, like two-dimensional array, this type of things. And also I'm going to discuss some problems which often comes during um, which often comes as tricky questions. I'm going to discuss those as well, so do subscribe to stay tuned, and you will be updated whenever these videos are released. Thank you so much.